The rectangular array of elements in rows and columns is called a matrix. Number of rows into number of columns will give the order of a matrix. So a matrix having only one column is called a column matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are same. Hello dear students, I am Mr. M.J. Niranjan, Faculty of Mathematics, Vidyaashram PU College. Welcome to this session of mathematics class. Now, today I am going to discuss regarding the first chapter, matrices and determinants. So, the first chapter you are going to study is matrices and determinants. This is a very important and very easy chapter. In this chapter, you may expect 1 mark 1 question, 2 marks 2 question, 3 marks 2 questions and 1 6 marks question. So totally this chapter will fetch us around 17 marks and also very easiest chapter. In this chapter, you don't study any formulas, anything, just only the basic arithmetic like addition, subtraction, multiplication, that's all. So that is why this is very important and easy chapter. So this contains 1 mark 1 question, 2 mark 2 questions, then 3 marks 2 questions, 1 6 marks essay type question. So in this chapter you are going to study regarding matrices, definition of matrix, types of matrices, operations on matrices, algebra of matrices like addition of matrices, subtraction, difference of matrices, multiplication. Two types of multiplication, one is scalar multiplication, another one is the matrix multiplication, problems based on these operations on matrices. Then you are going to study regarding some concepts like symmetric, skew symmetric, the transpose, problems based on symmetric, skew symmetric and transpose. Then very important concept you are going to study in matrices is adjoint, that is cofactors, adjoint and inverse, invertible matrices. Once if you know how to solve the problems in inverse, then you are going to solve the problems easily in matrix equations. Then the second part of the chapter is the determinants. Here also you are going to study the definition of a determinant and the expansion of a determinant, evaluation of determinants, finding the value of a determinant in case of 2 rows and 2 columns, problems based on those and little bit properties of determinants. So these are the things you are going to study in this chapter. Now, so as I told, this is very important chapter. This chapter fetches around how many marks? So totally it contains 1 mark 1 question, 2 marks 2 questions, then 3 mark 2 questions and 1 6 marks. So 6 plus 6 9, 9 plus 3 is 12, 12 plus 4 16 plus 1 is 17 marks. So this is very important chapter, 17 marks. So easily you will get 17 marks from this session. So now let me start with the definition. So what is the definition of a matrix? This matrix plays very important role in almost all fields of science and mathematics, science and engineering. Even in economics also we are using this to analyze the graphs as well as to write the equations and also to solve the simultaneous equations using simplest method, using Cramer's rule or a matrix method. Now let us define what is a matrix. What is the definition of a matrix? So the rectangular array of elements, the rectangular array of elements in rows and columns is called a matrix. Very simple. The rectangular arrangement of elements, rectangular arrangement of elements in rows and columns is called as a matrix. So this is an example for a matrix: 1 5 minus 9 2 4 5. So here I will take one example. If A is equal to 3 2 4 6 1 7. So the elements are arranged in a rectangle. How these are arranged? These horizontal lines are called as rows. The horizontal lines are called as the rows. The horizontal lines of elements are called as the rows, and the vertical lines, these lines are called as the columns. So this is first column, second column and third column. So these are called as the columns. The horizontal lines are called as the rows, first row, second row, and the vertical lines are called as the columns of a matrix. So the arrangement of elements in rows and column, that is the rectangular arrangement of elements in rows and columns, is called a matrix. The horizontal lines are called as rows and the vertical lines are called as columns. So these are all called the entries inside the matrix. They are all called as the elements of a matrix. So here this is first row and second row, whereas these are called the columns. So this is first column, second column and third column. They are called as the columns of a matrix. The rectangular arrangement of elements in rows and columns is called as a matrix. The horizontal lines are called the rows and the vertical lines are called as the columns of a matrix. That is a simple definition. Now next, after knowing the definition, let us know regarding the order of a matrix. What is the order? Actually, the order of a matrix will determine the number of elements present in that matrix. So the order of a matrix is defined as the number of rows into number of columns. The number of rows into number of columns is called the matrix. A matrix having m rows and n columns is denoted as m into n. A matrix having m rows, so m rows and n columns is called a m into n, m cross n, m into n matrix. Now for example, let us consider this example. A is equal to 1 first row, second row, third row. So this contains first row, second row and third row. How many columns? This is first column and second column, first column and second column. So this contains 1, 2, 3, 3 rows and 2 columns. So therefore the order of the matrix is 3 cross 2, 3 into 2. So this contains first, second, third, first row, second row, third row, and first column, second column, third column. So therefore the order of the matrix is 3 cross 2. Now let us come to this problem. So how many rows are there? There are 2 rows and 2 columns. So this is first row, second row, first and second row, first and second column. So the order for this is 2 cross 2. It is 2 into 2 matrix. Here how many number of elements? 3 2s are 6. So this contains 6 number of elements. Whereas this contains 2 into 2. It contains 4 elements. So the order of a matrix will determine the number of elements present in that matrix. Further, the order of a matrix can be written as rows into column. Number of rows into number of columns will give the order of a matrix. Okay, very simple. Now, let us take one more example. I will take this example. A is equal to 3, 2, 0, 1, 2, 4, 0, minus 1, 2. What is the order here? The order for this matrix is first row, second row, third row, 3 rows. First row, first column, second column, third column. This contains 3 rows and 3 columns. Third order, 3 rows and 3 columns. Let me take one more example. B is equal to 1, 2, 4. What is the order? This contains how many rows? Only one row. It contains only one row. How many columns? This is first column, second column, first column, second column, third column. So 1 into 3. The order is 1 into 3. Only one row, first column, second column and third column. Let me take one more example. C is equal to, I'll write on the same elements in this method. So the order for this is, this contains first row, second row and third row. So 3 rows. How many column? Only one column. Right. So this is 1 row, 3 column. This is 3 row, 1 column. Suppose if I take, so this is a matrix of order 1 into 1, that's all. Right. So the order will determine the number of elements present. Therefore, the order of a matrix is defined as rows into column. So the order of a matrix is always equal to rows into columns. Keep it in mind. So to write the order, first take rows and then column. That is the definition for order of a matrix. Now let us come to the general representation of an order of a matrix. Suppose if a matrix contains m rows and n columns is denoted like this. This above example is a representation of a matrix having m rows. Listen, first element a11, a12, a13, a1n, it is a1n. So it contains first row 1 1, 1 2, 1 3, 1 4, etc. 2 1, 2 2, 2 3, 2, etc. 2n, 3 1, 3 2, 3 3, etc. 3n. M rows 1 2 3 4 5 6 7 8. M rows 1 m1, m2, m3, mn. Last element is m. So this is first row. See here, first row, second row, third row. M rows and columns. First column, second column, third column, nth column. So n column. So that means this is a matrix of order m cross n. So it contains 1, 2, 3, 4, etc. 5 m rows and 1, 2, 3, 4, 5, 6 n columns. This is a matrix of order m rows and n columns. So in general, this is a representation of a matrix of order m rows and n column. Now the very important concept here is this. While constructing a matrix in the examination, you will get one more question. Construct a matrix of order 2 rows 2 column, 2 rows 3 column, 3 rows 3 column. For that, for 2 rows 2 column, just consider these elements a11, a12, a21, a22. So a matrix of order a11, a12, a21 and a22. Suppose if you want to construct a matrix of order 3 rows 3 column, then we are taking this another matrix. So a11, a12, a13, then a21, a22, a23, a31, a32 and a33. Right. Suppose if you want 2 rows 3 column, 2 rows a11, a12, a12 and a13, a21, a22, a23. This is 2 rows and 3 columns. This is 3 rows and 3 columns. This is 2 rows and 2 columns. So this is the general representation of a matrix of order 2 rows 2 column, 3 rows 3 column and 2 rows 3 column. So this we are using while constructing the matrices of any order. So in general, any matrix of order m cross n, m rows and n columns is denoted as 1 1 1 2 1 3 a1n, a21, a22, a23, etc. a2n, a31, a32, a33, etc. a3n. Number of terms, etc. am1, am2, am3, etc. am. So it contains 1 2 3 4 5 6 m rows and 1 2 3 4 5 6 n rows. So this is a matrix of order m rows and n columns. This is the general representation of a order of a matrix. The next concept is very important, types of matrix. Usually you will get one definition from these types of matrices for 1 marks. So there are different types of matrices. Now let us start with the first one is the row matrix. Row matrix. Row means just one row. A matrix having only one row is called a row matrix. That's all. A matrix having only one row is called a row matrix. So for example, A is equal to 1, 2, 3. This is a row matrix of order 1 into 3. It contains one row, first column, second column and third column. So it contains 3 columns. First row, first column, second column, third column. This is a matrix of order 1 into 3. Whereas this is a matrix of order 1 row, 2 column, first column and second column. So 1 into 3 it contains 3 elements, 1 into 2 it contains 2 elements. Let us take another example. Let's take AC is equal to 4, 5, 6, 8, 9. This is a row matrix of order 1 row. How many columns? 1, 2, 3, 4, 5. 5 columns are there. Let us take one more element. So one more matrix. This is a matrix of order 1 row and how many columns? 1, 2, 3, 4. Another matrix. Let us take this. This is a matrix of order 1 row and 1 column. So a matrix having only one row. A matrix having only one row is called a row matrix. So these are all example for row matrices. ಒಂದೇ ಒಂದು row ಇರುತ್ತೆ ಅಷ್ಟೇ, ಎಷ್ಟಾದರೂ ಕಾಲಮ್ಸ್ ಇರಲಿ. Now let us come to the second type of matrix. After row matrix, the next matrix is the column matrix. Column matrix now you can define easily. How to define? A matrix having only one column. A matrix having only one column is called a column matrix. So for example, a matrix having only one column is called a column matrix. For example, A, B, C. This is a column matrix of order 1 row, 2 row, 3 row. It contains 3 rows, first, second and third row, 3 rows, but only one column. This also contains first row, second row, third row, 3 rows, one column, whereas this contains first row, second row. This is first and second row, 2 rows and 1 column. So a matrix having only one column is called a column matrix. Let us take one more example. D is equal to another example, 4, 5, 6, 9. This is a column matrix. It contains only one column, but number of rows 1, 2, 3, 4, 4 rows and 1 column. Let us take E, another matrix, 4, 6, 9, 10, 11. So this contains 1, 2, 3, 4, 5. 5 rows, 1 column. These are all example for a column matrices. So in general, a matrix having only one column is called a column matrix. So these are all example for column matrices. Now let us come to the next type of matrix, is a square matrix. Square matrix. Square matrix. Square means what? So you know in square same. So a matrix having number of rows and number of columns are same. A matrix in which the number of rows is equal to number of columns is called a square matrix. A matrix in which the number of rows are equal to number of columns is called a square matrix. A matrix in which the number of rows is equal to the number of columns is called a square matrix. For example, this is a square matrix. First row, this contains first, second, third, 3 rows. First column, second column, third column. So the order is 3 into 3. So number of rows is equal to number of columns. So this is a square matrix of order 3. So here 2 rows and 2 columns. First row and second row. First column, second column. Therefore this is a square matrix of order 2 into 2. Whereas this is also a square matrix of order 1. So these are all square matrices of order 3, 2 and 1. So usually you are going to study square matrices of order 3 and 2. You don't have square matrix of order more than 3. So another example, let us take for example. I will give just an example. This is also a square matrix. The order for this is 4 cross 4. But in your syllabus you are going to study only square matrices of order 2 and 3. 2 means 2 cross 2 and 3 means 3 cross 3. So this is another example. This is also a square matrix of order 2 cross 2. Though all the elements are zeros, this is an example for a zero matrix. I will explain what is zero matrix, but this is also a square matrix. So very important concept. Square matrix means a matrix in which the number of rows is equal to number of columns is called a square matrix. So we are going to study only square matrices of order 2 and 3, 2 cross 2 and 3 cross 3. Now let us come to the next concept. So in a square matrix, the very important concept, in a square matrix, the elements from left top corner to the right bottom corner, the elements from left top corner to the right bottom corner are called principal diagonal elements. The elements from left top corner to the right bottom corner are called principal diagonal elements, or it is also called as leading diagonal elements. So here in this example, 1 to 9 are the principal diagonal elements. 1 to 9 are the principal diagonal elements. These elements are the principal diagonal elements. So the elements from left top corner to the right bottom corner are called the principal diagonal elements. So here 1 to 9, these 1 to 9 are called the principal diagonal elements. Okay, whereas the elements from left top, yes, Here right top corner to the left bottom corner are called as the secondary diagonal elements. Here what are the principal diagonal elements? 1, 2, 9. Secondary diagonal elements are 7, 2 and 4. So these are called the principal diagonal elements, and whereas this 7, 2, 4 are called as the secondary diagonal elements. So keep it in mind, this is very important concept. So in a square matrix means number of rows is equal to number of columns. In a square matrix, the elements from left top corner to the right bottom corner are called principal diagonal or leading diagonal, whereas the elements from left bottom corner to the right top corner are called as the secondary diagonal elements. In this example, 1 to 9 are the principal diagonal, 7 to 4 are the secondary diagonal elements. Let me take one more example. If I take A is equal to 3, 4, 6, 1, 2, 5, 0, 9 and 7. Here these are the principal diagonal elements. So in case of another matrix, B is equal to 2, 0, 0, 5. These are the principal diagonal elements. So the elements from left top corner to the right bottom. So we are considering majority times only the principal diagonal elements. Now knowing these diagonal elements, let us define the diagonal matrix. Now let us define a diagonal matrix. You know what are diagonal elements? So diagonal matrix is very simple. First of all, it is a square matrix. It is a square matrix. A square matrix A is said to be diagonal matrix if all the non-diagonal elements are zeros. All the elements are zeros except the principal diagonal elements. All elements are zeros. This is an example for a diagonal matrix of order 3. So is a diagonal matrix of order 3. That is, all the elements above the principal diagonal and below the principal diagonal are zeros. All the elements are zeros except the principal diagonal element. So it is a matrix. A square matrix is said to be a diagonal matrix if all the non-diagonal means other than this diagonal, all elements are zero. Principal diagonal. Now let us consider one more example. Let us take B is equal to 2, 0, 0, 0, 6, 0, 0, 0, minus 1. This is also an example for a diagonal matrix. Another matrix 4, 0, 0, 5. This is also an example for a diagonal matrix. Consider one more example. D is equal to minus 1, 0, 0, 3, 0, 3, then 0, 0, 4. This is also an example for a diagonal matrix of order 3 rows, 3 columns. Suppose if I write A is equal to 2, 0, 0, 0, 5, 0, 0, 1, 3. This is not a diagonal matrix. This is a square matrix but not a diagonal because this 1 is not equal to 0. So it's provided if 1 is equal to 0, then only it is a diagonal matrix. Followed? So I think you got an idea what is a square matrix, what is a diagonal matrix. Now suppose if all the diagonal elements are same, what you are going to get? Suppose if all the diagonal elements like 2, 2, 2, 6, 6, 6, 4, 4, minus 1, minus 1, minus 1. Then we will have a special definition for that. That is called as a scalar matrix. Scalar constant. So a diagonal matrix is said to be scalar matrix if its diagonal elements are same or equal. If all the diagonal elements are same, equal, then it is called a scalar matrix. Very important definition for the point of examination. We will get one more question. Define a scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are same. For example, 5, 0, 0, 5 is a diagonal scalar matrix of order 2 rows, 2 columns. 3, 0, 0, 0, 3, 0, 0, 0, 3 is an example for a scalar matrix of order 2. So these are the scalar matrices of order 2 and 2. So another example, I will take 1, 0, 0, 1. This is also a scalar matrix, but this will have a special name that I will explain. Another matrix B is equal to 2, 0, 0, 0, 2, 0, 0, 0, 2. This is also an example for a scalar matrix. So, all scalar matrices are example for diagonal matrices, but all diagonal matrices, provided all the diagonal elements are same, then only they are scalar matrices. So, followed. A scalar matrix means it is a diagonal matrix in which all the diagonal elements, principal diagonal elements are same, or you can also define like this. It is a square matrix in which all the elements are 0 except the principal diagonal, and the principal diagonal elements are same. The lengthiest definition, but easiest simple definition is a diagonal matrix is said to be a scalar matrix if its diagonal elements are same. Give one example, that's all. Now, let us come to the next type of matrix. Next definition is identity matrix, or it is also called as a unit matrix. Identity matrix, or it is also called as an unit matrix. So, a square matrix in which all the principal diagonal elements are equal to 1. This is very important. If all the principal diagonal elements are equal to 1 and other elements are zeros, is called an identity matrix, and it is denoted as I. So, here I is equal to, so define, again I will define this. A square matrix in which all the principal diagonal elements are equal to 1. All the principal diagonal elements are equal to 1 and other elements are 0 is called an identity matrix, and it is denoted as I. This is an example for an identity matrix 1 0 0 1. All the diagonal elements are equal to 1, other elements are 0. 1 0 0 0 1 0 0 0 1 is an identity matrix of order 2 and 3. So let me take one more example. I is equal to 1 0 0 0 0 1 0 0 0 0 0 0, this is 1, sorry, 1, again 0 0 0 1. This is an identity matrix of 4 rows 4 columns, but you don't have, but general. So this is not an identity matrix. This is not an identity matrix, just it is a square. This is not an identity matrix. Okay. So here, if all the principal diagonal elements are equal to 1, then only it is called an identity matrix. Okay. So all identity matrices are example for scalar matrices, but all scalar matrices are not identity matrices, because in scalar matrix all the diagonal elements are same. So 1 0 0 0 1 0 0 0 1 is an example for a scalar matrix, but in identity matrix all the scalar elements are equal to 1, right? So therefore all identity matrices are example for scalar matrices, whereas all scalar matrices are not identity matrices, provided if the diagonal elements are equal to 1. So this is also a very important definition. The next, coming to the last type of a matrix, is the zero matrix, or it is also called as a null matrix. Zero matrix or null matrix. Zero or null, nothing. All the entries are zeros, that's all. So a matrix in which all the elements are zeros is called a null matrix or a zero matrix. A matrix in which all the elements are zeros is called a null matrix, whatever may be the order, irrespective of the order. This is non-square matrix. So example, this is an example for a zero matrix of order 1 row 1 column. This is a zero matrix of order 2 rows 2 column. This is a zero matrix of order 2 rows and 3 column. So denoted as 0. So let me take one more example. 0 is equal to 0 0 0 0 0 0. This is also an example for a zero matrix of order 3 rows 3 column. Let us take one more example. This is also a zero matrix of order 3 rows and 2 columns. 3 rows and 2 columns. So a matrix in which all the elements are zeros is called a zero matrix or a null matrix. It is denoted as 0. These are all example for null matrices or zero matrices of order 2 cross 3, 2 cross 2, 3 cross 2, 3 cross 3. So usually a null matrix is denoted as 0. 0 0 0 0 0 0 0 0. This is a null matrix of order 3 rows and 3 columns. So that means in types of matrices we have studied, first one is row matrix, column matrix and a null matrix. These are non-square matrices. Remaining all comes under square matrices. So very important is the scalar matrix, identity matrix are very important definition. Now coming to this, now let us discuss regarding few 1 mark questions, 1 mark problems, 1 mark problems. Let us discuss some 1 mark problems. So usually you will get 1 mark or question, 1 mark question from these concepts. So as I told, while writing the order will give the number of elements present in a matrix. Now here a matrix has 8 elements. What are the possible orders it can have? So a matrix having 8 elements. There are 8 elements in a matrix, and what are the possible orders? Very simple, just factorize, simplify this, multiples of 8. So here, so 1 into 8 factors, that's all, factors of 8. 1 into 8, 8 into 1. Next 2 into 4, 4 into 2, remaining 3 you can't write, 3 3s are 9, you won't get again, that's all. So therefore the possible orders are, so 1 into 8, 8 into 1, 2 into 4 and 4 into 2. How many possibilities are there? There are 4 possibilities. So a matrix having 8 elements can be constructed in 1 into 8, 1 row 8 columns, or 8 rows 1 column, or 2 rows 4 column, or 4 rows, first, second, third, 4 rows and 2 columns. So this is how you are going to construct. So keep in mind, if it is a even number, you will get the factors. If it is an odd, let us consider one more example here. Write all possible orders if a matrix having 13 elements and 24 elements. Let me write for 13 elements first. This is an odd number. So if a matrix having 13 elements means, what are the possible orders? So 1 into 13 and 13 into 1, that's all. You can't factorize with 2, 3, 4, anything. So therefore the possible orders are 1 into 13 and 13 into 1. Suppose if you have 17, 1 into 17, 17 into 1. Suppose if you have 11 elements, 1 into 11, 11 into 1. Right. Now, whereas if you have 24 elements, construct a matrix having 24 elements. So 24 can be factorized as, first take 1 into 24, again 24 into 1. Next 2 into 12, 12 into 2. 3. Factors of 3. 3 into 8, 8 into 3. Again 4. 4 into 6, 6 into 4. 5, 6, 7. So all possible orders are, the possible orders for this matrix having 24 elements are 1 into 4, 24 into 4, 2 into 12, 12 into 2, 3 into 8, 8 into 3, 4 into 6, 6 into 4. So possibilities are 8 possibilities are there. This is how we are going to construct a matrix depending upon the number of elements. This is the construction of a matrix whenever the number of elements are given. Now here, next very important 1 mark question. This is also very important for the point of examination. What is the problem given? Construct a 2 cross 2 matrix. What are the elements? A is equal to Aij, where Aij is equal to ijth row, I row and j column, I by j. This is the given condition given. So let us consider A is equal to Aij. The given condition is I by j, and the order is, what is the order you want? 2 into 2. So now, while constructing a general matrix of order m into n, I explained what are the elements you are going to take. A is equal to 2 rows 2 column is A11, A12, A21, A22. This is 2 rows and 2 column. First element of first row, first column, first element of second row, first element, this is first row, this is column, this is also column. So first element of first row, first column, again first element, yes, first element of column number 2. Similarly, first element of this row 2 and second element of row 2. So here this condition, what is the definition given? I by j, ij and ij. I is 1, j is 1. I is 1, j is 2. I is 2, j is 1. I is 2, j is also 2. So ij form 1 1 1 by 1, 1 2 1 by 2, 2 1 2 by 1, 2 2 2 by 2. So you will get 1 by 1 as 1, 1 by 2 half as it is, 2 by 1 is 2, 2 by 2 is equal to 1. This is a matrix of order 2 rows and 2 column. So this is a matrix of order 2 rows 2 column. Very simple. So just write down A11, A12, A21, A22. What is the condition given? I by j, 1 by 1, 1 by 2, 2 by 1, 2 by 2, 1, 1 by 2, 2 by 2, 2 by 1 is 2, 2 by 2 is 1. Now, on the other hand, what is they ask? Construct a matrix of order 3 rows 3 column, given that Aij is equal to 2i minus j. So for this, A is equal to 2 rows and 3 column. 3 rows and 3 column. 3 into 3. What are the elements? A11, A12, A13, A21, A22, A23, A31, A32 and A33. So multiply first element with 2 and subtract the second element. Multiply with 2 and subtract the second. So like this you will get the answer. Let me solve this problem here. So let me solve. I will rub this. So I will take A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, continuation. Now, what is the condition given? I minus j. See, first I will write one step here for your reference. A11, first element. What is the condition given? 2i minus j. So 2 into I is 1 minus j is 1. So 2 minus 1 is equal to 1. The first element is 1. First. Second, come to the second element, A12. A12. So 2 into I is 1 minus j is 2. So 2 minus 2 is 0. This is 0 you will get. Another matrix, another element A13. What is the condition? 2i. 2 into 1 minus this 3, that is 2 minus 3 is minus 1. Similarly, A21. A21. So what is the condition? 2i minus j. So 2 into I is 2 minus 1, 2 to the 4 minus 1, that is equal to 3 here. Again A22, 2 into I is 2 minus j is also 2, 2 to the 4 minus 2 is equal to 2, this is 2. Again A23, 2 into I is 3, 2 minus 3, that is 4 minus 3 is equal to 1, this is 1. Last A31, so A31, 2 into 3 minus 1, that is 6 minus 1 is 5. Next A32, 2 into 3 minus 2, 6 minus 2 is equal to 4. Last A33, so that is 2 into 3 minus 3, 6 minus 3 is equal to 3. So this is a 3 cross 3 matrix. All the elements are of the form 2i minus j. This is an example how you are going to construct a matrix under given condition. Suppose if you want to construct a matrix, let us consider if Aij is equal to I plus j whole square of order 2 cross 2, of order 2 cross 2. Now let us take A is equal to A11, A12, A21, A22. What is the condition given? I plus j whole square, I plus j, that is 1 plus 1 whole square, again I plus j 1 plus 2 whole square, next ij 2 plus 1 whole square, 2 plus 1 whole square. So this is 280, 2 plus 1 whole square, then 2 plus 2 whole square. So this is equal to 1 plus 1 is 2 square is 4, 2 plus 1 is 3 square is 9, 2 plus 1 is 3 square is 9, 2 plus 2 is 4 square is 16. This is a 2 cross 2 matrix. So this is how we are going to construct. So what we have studied, a definition, a matrix is nothing but the rectangular arrangement of elements in rows and columns, and the order, the number of rows into number of columns will give the order, and the types of matrices, row matrix, column matrix, then square matrix, number of rows is equal to number of columns, then diagonal elements, diagonal matrix, scalar matrix, all the scalar elements must be equal, that is diagonal elements must be same, other elements are zeros in a square matrix, then identity matrix and a null matrix, and the construction of a simple matrix of a given order depending upon the given conditions. These are the things we have studied. So in the next class we are going to discuss regarding the algebra of matrices like addition, subtraction, scalar multiplication, and matrix multiplication. So that's, thank you.